So thank you for joining me this morning. I'll talk today about, testing RESTful web applications. I'll try to both keep it interactive, so let you ask questions in the middle, but do keep the pace of the presentation. So if at one point I tell you, we're running out of time, sort of let me go through. Keep your questions. I'll answer them either at the end or personally later on. So a word about myself. The picture is for the slides that are online later on. You can see me here. Of course, the picture would always look better than I. I'm sort of a person that I never know what I am. I do product management today, which means I'm a bit more on the business side, but my heart and soul is research, mostly around application security. Today I work at HP ArcSight division. Until a year ago, I ran research at Fortify, still HP. So I sort of come here. My reason for coming here is keeping in touch with research, with the community. Talking about community, I'm in OWASP, very active at OWASP. I started the Israeli chapter. I ran a few open source projects. They're all listed here. A fun fact about myself is that the airport closest to where I live is Damascus. I've never been there. I mean, you've read in the papers what's going on there. So did I, read in the papers what's going on there. I live on the other side of a sealed border in the first world, and 40 miles from me, the third world starts. And I drive to Tel Aviv because it's a 80 miles per hour freeway, even though it's a 120 miles drive. The second closest, by the way, would be Beirut. So.
You don't select a nearby airport when you do planning, travel planning?
No. I wonder how it would work. I never tried. I write TLV, which is our airport. I never tried nearby. It would be fun. Okay, what are we going to talk about today? So we're talking today. RESTful web services are becoming a major part of web development, and are very challenging for pen testing. And I broke the presentation into parts because I think many people don't know what RESTful web services are, and if they know just about what they use as RESTful web services. So I'll try to portray a picture of what really it is and what it isn't. Then I'll discuss in a very small number of slides, how widely they are used, where they are used, stuff like that. And then I'll get into pen testing. I'll first discuss manual pen testing, so challenges associated with actually getting after RESTful web applications. And then I'll move into what I did at Fortify at the time, which is trying to solve essentially the same issues, but from an automated scanner point of view. So this is interesting, but it's a bit more for if you write tools rather than if you do pen testing yourself. But all of us script our way around, so might be useful anyway. Okay, so RESTful web services. So what are web services to start with? We hear the term so much. It's worth spending a minute understanding what it is. So we all use the web daily. Web services are usually a term which refers to inter-application communication. So when you want to use the web technology to connect two applications. So it's not any more human interaction with the web, with web servers which matters. It's an application-to-application interaction which matters. One thing to note, of course, when I'm using an application to control my presentation is today the client is also an application. It's true to phones, but it's true also to rich web applications, whether it's rich as in Flash technologies or rich as in HTML. Moving to HTML5, essentially the difference is null. So HTML5 applications are pretty complex applications. So those technologies, even though they are client-side and are used by end user, are very applicative and use web services to communicate with the web server. Example. It's not the most common anymore. I used to say it's the most common, but it's not. Flavor of web services is something called SOAP. think S stands for simple. However, everything that this does is just getting a stock quote, so a single stock quote. So SOAP is a very, very highly documented, formalized way to use web services to interact between applications. It's based on XML payload and XML results, and there's tons of standards around that, and on the other hand, it makes it hard to use. Also, it's not bandwidth efficient because there's just a lot of XML there. All I wanted to do here was send the IBM value, and on top of that, I had to write all of that just to send essentially one 3-letter parameter. So, web services are giving way. Sorry, that's previous and not next. Application UI bug. So web services are pretty common. They're used a lot inside organizations when they try to do their sort of messaging bus between internal applications, but they are hard to use. One thing worth mentioning, I won't go into details here, is that they are considered by the industry as secure. There's tons of security standardization around them, something usually called WS star because it stands for a number of WS web services standards around single sign-on and session management and authentication, even authorization, and how to sign the traffic and all that stuff. There is a good argument left to a different presentation that this does not really bring a lot of security to SOAP web services. It never gets to SQL injection, of course, which can go through that just as it can go through any other input mechanism. And that it's so complex. It's so complex that people are just not using that. So off we go with SOAP. Here we go with REST. So REST is an interesting concept because essentially RESTful is a design pattern. It's a way to look at things. When we get in the next slide to RESTful web services, we'll try to understand what it means to the same use case of connecting applications to each other. However, RESTful design is essentially a design pattern. It is a philosophy of how to do things right around essentially APIs. And essentially the RESTful design pattern is the basic building block or design pattern for the most pervasive technology out there, which is just the web. So Web 1, so to speak, is a RESTful implementation. It's not a web service because it's not for interacting between two applications. It's usually used for interacting between a user and an application. Now, I won't go into details here. They'll be very boring. That's why I don't want you to look like the guys behind the slide there. But if you think about what you do in the web, that's essentially REST. It's using URLs to access the functionality you are looking for. It's stateless, no session, which is one of the most horrible things about the web security-wise, but it's still part of the design pattern because it makes everything much more simple. And it's supposed to be uniform in some way. Let's get into details, which will be much more sort of easy to understand as to how this design pattern is actually used for interacting between applications, so for RESTful web services. So, one thing that I need to mention is that RESTful web services are not a well-defined protocol. Unlike SOAP, which is highly defined, RESTful web services are different ways to use the design pattern that's called REST in order to do inter-application communication. So I can't really share with you the spec for RESTful web services. What I can share with you is common practices for RESTful web services. Of course, this makes it quite a challenge to test them because you don't even know they're there. And we'll touch on that in following slides. So essentially, the simplest RESTful web service you can have is taking everything in this SOAP message and putting it in a URL. So apart from changing IBM to HP, which depending on the day is not a good idea if you own stocks, you do save one character though. You can see that this is a much simpler method for doing essentially the same thing. And that's why it's very compelling. That's why it's used a lot in mobile applications, in Web 2 applications. It's just so much simpler. I mean, think about programmers. They want this, they don't want that. However, there are implications. Not all information is as easily sent, and we'll see it about both security, pen testing in future slides. So a few sort of common practices. One thing which falls very, very directly on the design pattern is using methods to determine the actual action you would want to take with regard to the URI. So the URI specify sort of the resource you want to access. The method specify what you want to do with the resource. A very commonly used term is CRUD, which stands for CRUD, create, read, update, and delete, which are 4 functions you want to do over essentially objects. So those translate very well into file management, and you'll see REST used very widely around anything that has to do with cloud and files. So Amazon Web Services, Box.net, all of them, Dropbox, all of them use RESTful web services that are very, very focused on the CRUD design pattern, providing access to the file system from remote. However, not everything we want to do is file access, and many times delete, for example, is not meaningful. There are other sort of practices that are used a lot around RESTful web services, and one of them is, where do I put the parameters? So there's no standard around that. That's probably one of the major pain points of understanding RESTful web services, dealing with them quality-wise and security-wise. You'll find that parameters are passed in many different ways. So we've seen the example where parameter is part of a URL. This is a pretty common one. Many times it's implemented in practice in web server by something called URL rewrite, which means that the URL looks to you like it's a file, but essentially it actually is a set of parameters, and Apache has actually IS as well these days, have a whole module around actually to take it before the application gets it and translate it into normal parameters. But it doesn't stop there. Headers are used a lot for as parameters. So now the headers are also parameters. And that gets us into pen testing, because most of us will fuzz parameters if they look like request parameters or post parameters, but we rarely fuzz headers. I mean, we read a lot in research about vulnerabilities in headers, but in practice, that's not where we'll go first to search for SQL injection. But those are just regular parameters, so why not? Another thing we would want to look into are composite parameters. So a lot of times, usually JSON, at times XML is used as a container for parameters in RESTful web services. Of course, XML getting us back to the SOAP era, just without the complexity and overall structure. JSON will be much more sort of shorter and therefore loved by programmers. The issue there is that now, when the application gets it, it treats each of the values separately. So just injecting the JSON itself would usually break the first minute, because the JSON parser would just throw it away. However, if you inject any of the parts, any of the embedded parameters, the risk for vulnerability is still very much there. Okay. Keep in mind that the result might also be a JSON payload. The only thing I've seen around that, which is security related, is that in many cases, JSON is executable JavaScript. So this is just directly executed by the application to derive the values. And if it's not valid JSON, if it's not valid data but valid JavaScript, it might be run as code back on the application, which opens an opportunity for different types of cross-site scripting attacks. Lastly, I think there is a challenge which is always a challenge for web applications, which is authorization and session management. There is no common way in the web world to actually do that, which, by the way, is a major challenge for pen testing. Always, it's a huge challenge for automated pen testing. I don't know if you've tried. Anyone here is using a scanner, a web application scanner? Which one? Burp? Same? Any commercial one? Burp is commercial actually, but any commercial one? AppScan, WebInspect, somebody, AppScan. Okay, so in all those, and actually the way you can tell a mature web application scanner from just an early stage one is how does it handle login. How do you go over the login phase and still and scan all the activity that may exist after login? Because there's no standard way to do that, it might be a complex application-oriented process. Just think about a CAPTCHA and a scanner. Makes it hard. So just like with interactive web usage, RESTful web services are very, very not standard around how they handle authentication and session management. Few common practices to be aware of are that authentication is many times done using basic HTTP authentication. So essentially sending a username and password in the header. Therefore, many times RESTful web services rely on SSL for security, because the only thing that actually protects those credentials is SSL. You'll many times find that RESTful web services security is nearly equated with SSL for that reason. As we all know, SSL has its limitations, not because I'm afraid of somebody breaking into SSL, but because of gateways, proxies, just bad implementation that leaves some of the site out of the SSL range and some within the SSL range. The next phase is how do we do a session management. In most cases, nearly most RESTful APIs would provide you with some kind of token back. So you'll send your credentials, get a token back. It has a lifetime. In essence, this is an alternative to cookies. It's just a managed alternative to cookies. So it's not stored in, because it's an application calling rather than a browser. There's no need to use the cookies mechanism, which is sort of a token automatically maintained by the browser for the user. An application can receive the token and know where to use it. So actually, it's more secure than cookies because it's under the control of the application, but it's not that different, and it might have many of the challenges you are aware of with cookies. I mean, you could steal those tokens just the same. An interesting point to note is that the design pattern itself, due to purity reasons, calls for including the session ID in the URL, not in a header. Some implementations do that. It's very insecure because URLs are often logged. They are easier to steal. Most more major mature implementations of RESTful API would have this token in a header, nearly 100% actually these days. Another thing to keep in mind is that since it's an application-to-application interface, there's a major SSO aspect to it, SSO being single sign-on. So I have a client application. It got a token from a specific service. When you start to build your entire sort of infrastructure, application-wise, you want this token to be valid also on a different service that's associated with it. And this is very challenging. There is no standard around that. Usually it involves some back-end communication. The first server would tell the second server this is an OK token. But I've seen areas where sort of the client gets to get the information that allows it to get to the second server. It might be well encrypted. That's not a bad design pattern. It might be a weakness. Now, one last aspect I want to discuss about RESTful web services is their documentation. RESTful web services, so SOAP web services are often, nearly universally, actually described as something called a WSDL, WSDL, which is Web Services Description Language. So, and since it's very highly structured, it's easy to define in a very, oh, you can't see the numbers, in a very formal way. With RESTful web services, since there's so many variants, essentially no standard, and a parameter can be in one of dozens of different ways, it's hard to define. There is something called WADL, Web Application Description Language, which is an attempt, actually technically it can describe any variant of RESTful web services I've seen to date. It's not a standard, it's just a proposal, and it's not widely used. The numbers you can see here are my Google searches for both for actual files available on the internet, which have either WSDL files or WADL files, and this is around, I don't know, 200,000, which by the way is a security issue, if you think about it. Having WSDL exposed, sometimes it's intentional, many times it's not intentional. And for WADL, there are around 2,000, so 1% of those. And my guess is that it's not because when you write a RESTful web service, you know your security and you wouldn't put the WADL out there. It's just that it's not widely used. And we will see later, it doesn't imply that RESTful web services are less widely used. It just implies that they're less well documented. And that's a big challenge. When we go to test something, we need to know as much as we can about it. And we'll see that even though normal applications are not documented well, we have our ways to find the attack surface. For web services, there rarely is a good way to do it apart from documentation. And if there's no documentation, we have a big, big challenge. Okay. So that was sort of a primer to RESTful web services. I hope you get out of here knowing a bit more about RESTful web services, sort of getting it from a buzzword level to something which is tangible. But the bottom line is that it's the web as you know it applied to inter-application communication. So a few slides about where can you find it in the wild. So I promised another Google search on the technologies. So I did the Google search on RESTful web services and SOAP web services, and you see that SOAP is declining, REST is on the rise, and actually since I last talked at Barcelona about this subject, and I did update the slide, we were even, and now we see that RESTful web services are actually gaining momentum over SOAP web services. Everybody is using that. I did not update this slide. I didn't go out and look for additional logos to put here. Essentially, every major web site, aggregator, whatever you call it, that exposes an API today does it using RESTful web services. It's becoming very common. So it's sort of de facto, that's the way things are done. That's good. One thing to keep in mind is that you will find, especially in the mobile application world, a lot of RESTful web services that their programmer never knew the name. Sort of, they implemented something that's RESTful web services, but they didn't call it this way. It does exhibit a lot of the characteristics that we've seen before, but it usually has a lot less security. Because if we talk, I talked about having a header as the token used for session management. If you write a RESTful API intentionally, you work it out. If it's just an app doing an API for itself, there are many cases where it's not done the correct way. So 2 slides about the security of RESTful web services, because I said quite a bit about that, and I think that the security itself is not different. It's the testing which is different, which we'll get to in the following slide. So first of all, REST is just the web. So if you know REST security, and if you're old and wise as this guy, you know RESTful web security, and a lot of things that you already know are there. I mean, it's a way to provide parameters to an application, and the same attacks work. I don't think there's any major change. In the next slide, I show a bit of sort of things to keep in mind. One thing to keep in mind is that there's a notion of security by obscurity that does not happen on web applications. Nobody really sees this API because it's between two applications, and therefore we test it less, which is what we'll talk about today, and the programmers tend to give less. Those programmers that will only protect and check well the login page because of the famous SQL injection around or 1 = 1, so they will do nothing around RESTful web services. Few things to keep in mind would be that there's no standard mechanism to do security, and therefore I'm talking about penetration testing. I do believe that you need to start any REST test with an architecture overview. There's a lot of architecture there. They have to build. There's no standard. You can't just expect, login cookies as you would in a web application, or WA stars you would expect in software services. Worth looking at what the people have done there. It's sort of a black and white picture usually. If somebody gave any thought to that, it would be okay. If not, I hope you got early on, because otherwise it would go live without changing, because it's hard to change architecture. I mentioned proprietary authentication and session management. And lastly, some smaller issues. I mentioned that people usually say, I have SSL, my RESTful web services are okay. The reason for that is because you need to protect the authentication key for sure, and the username and password if it's basic HTTP authentication. It's certainly not enough, but people will tell you that. Everything else I probably covered. Okay. A bit of a long introduction, but I think it's important because it's nearly half of the presentation, or because RESTful web services are not well understood. Let's get into actual pen testing. Okay. So I'll mention 3 or 4 challenges that are facing us regarding testing web application, RESTful web services. Then I'll show a few solutions, what you should do. Then we move to the automated part of it. So the first one is the application surface. Keep in mind that now the paradigm of you see a page, you know the parameters, you know the links, doesn't work anymore. There are a few reasons for that. First of all, it's generated by an application. So it might not be easy to view HTML in the first place. It might be still HTML, but done by using a lot of JavaScript. So only after tons of JavaScript execution, the actual RESTful call is done. And lastly, but not less important, once it's an API, there is no one-to-one correlation between what's implemented on the server and what's actually used by the client. So just looking at the client would never give you a full insight into the API. It might be 30%, it might be 70%, because it's now 2 teams, an application exposing an API, a client application using it. Just by looking at the client, you won't know what's the entire surface. So those were sort of the URLs. The second part is about the parameters. So assuming you know, at least resource-wise, URL-wise, what is the extent of the application, it's pretty hard to know what the parameters are. I'll mention 2 aspects of that. One of them we beat to death before was about what is a parameter. The second one is that, especially for unused APIs, or those it's hard for you to see the real request, it's hard to know what the base value is. If you think about it, when you do fuzzing, you do one of 2 things. You either send sort of a known attack vectors, or known vectors to solicit response that would indicate an attack, single quote, okay, for that matter, or you fuzz over the existing values. So you take the current values and look for the red herring, for the value which is out of range. And the second one is very hard to do when you don't have a base value. Base value is critical for that part. And it's hard when you don't have any example of the actual call. The result of that is that you need a lot more requests, a lot more attempts, which is not scalable when you do manual testing, and also pretty burdensome for automated testing. Okay. As I mentioned, the custom authentication is something that's a challenge, a relatively easy to solve one. Usually you can analyze that, but you should analyze that. So you need, in order to actually do testing, you have to understand the authentication mechanism, what is the actual session ID, and have a tool that knows how to help you with doing that. So for example, if you have a standard proxy which has a cookie jar that you can store a cookie there in order to preserve your session, it doesn't help anymore. You either need to manually update the header for each request, or you need to find a tool that knows how to keep a header on an ongoing basis, which is less common. So that's more of a tactical issue in the first two. And after I mention the challenges, let's look a bit at solutions. So first and foremost, probably the first thing to start with would be, and I mentioned that for RESTful web services, you may want to not dive directly into the application, but look into the architecture before. You may want to gather as much documentation up front as you can. Now, when I say documentation, it might not be just formal documentation as WADL, because there aren't that many of them. There are a few other places to look for that. So I have here an example of documentation, programming guide, and an example of something interesting. You may look into the configuration of the web server or whatever framework you're using, because in some cases, the configuration, let's call it the paracode, something that comes before the code, includes a lot of information about how the requests are translated into parameters, what is used as a parameter, because the programming language has a very concrete notion of a parameter. The interface you're using doesn't have it, so something in the middle would include this translation. One thing worth mentioning specifically would be configuration for your rewrite module on the web server. As I mentioned, in some cases at least, the translation from a uniform URL to a URL plus parameters is done on application on the web server level, and then the mod rewrite configuration would disclose to you what is the actual parameter. So in this example, essentially anything which is you think of as a URL is essentially passed as a parameter to index.php. So the rewrite rule checks for any URL and put the parameter as the parameter for index.php. So that's a simple one. It can be much more complex than that. Let's look at our two examples of potential sources. I mentioned WADL, of course. Lastly, the application source is a good way to go. And in many cases, you don't need to get into the sources and to dive into C code. In both .NET and Java, there are sort of frameworks to build RESTful web services, which imply that there is some configuration file. This is a .NET example that enable you to define for the code your RESTful web API. And essentially, you have it pretty well, the translation, very similar to the rewrite example of how you translate the request into code parameters. I won't get into the details here, but essentially you see here the patterns for the URL and then how they translate into a method call with the parameter used as a parameter. So you have names for parameters and how they're reflected in the URL. All those examples are for URLs. You will find, especially in documentation, I didn't see it in frameworks. Also, of course, documenting when headers are used as parameters or when JSON is used as parameters. So go to the documentation. I know it's harder. It's usually something we don't do as pen testers. That we just hit the application, and it creates a problem with the interaction with the customer because they're not used to providing that. I think it's important. So another thing you should use, you may use it today, it's important since Web 2 it's sort of critical, would be proxies, of course. I'll mention two things about that. First of all, use a proxy because you can't get all the URLs today in all the requests in the first place. So once we started doing Web 2, Ajax, you don't see all requests on the page. You'd use a proxy in order to get the request and understand what to send yourself. Or store the cookie value for that matter. So that's for sure. And for RESTful web services, that's nearly a must. One thing to remember, it's also a source for understanding the request structure, and we'll see later on to use that, especially in automated tools. So to sort of map the attack surface, what URLs are especially used. A point in question would, of course, be that for application, a point to remember is for applications, for mobile applications, there's literally no other way. You have to put that in the middle and fuzz here rather than fuzz on the client or on your own Python script. Okay, the third one I want to share with you before we get to automation, if I recall well, would be how to identify in a request parameters by looking at them. So directly addressing manual pen testing. So, of course, anything which is a non-standard header would be something you want to fuzz, something you want to inject to. So that's sort of easy. Look into the URL. Try to assess whether anything there looks like a parameter. Now, that's easy to say. Why would it look like a parameter? So one thing would be if it has a pattern of a parameter. If it doesn't look like a file name, a directory name, a date. You have a date in the middle, good chance it's a parameter. A long numerical value by itself, directories are not often called by long numerical names. Or anything which is just garbage, for that matter. If it's just letters and numbers, it's usually a session ID, by the way. So you can attack it as a session ID or as a parameter, for that matter. Thirdly, of course, look for structured inputs. They're visible. You can see them if it looks like JSON. By the way, it doesn't have to be JSON or XML. If you have a parameter that has sort of delimiters inside, keep in mind there's a good chance that you want to inject or test fuzz each part between the delimiters. So you'll have a value which is a semicolon Ofer semicolon ID number semicolon date. That's a compound value. You may find more vulnerabilities if you try to inject or fuzz each one of the parts than if you try to just replace everything by an injection string, because if you just try an injection string, it will be sort of found as an error by the parser itself that breaks it. While if you try each value by itself, you'll get to the actual code that processes this value, which would prove more efficient to find vulnerabilities. Lastly, somewhat interestingly, look for URLs with no extension. Usually, it's not always, but if there is no extension, there's a good reason to think it might be part of a RESTful API, because it's not a file. It can be a file. There's no reason it wouldn't be a file, but these are just heuristics. Nothing here is, pure science for that matter. So we've talked about testing RESTful web services. I mentioned that the attack surface is a major issue, both finding the actual URLs and, secondly, knowing what a parameter is. And that session management is somewhat challenging. Then I went into solutions, and I mentioned that to find the attack surface, you should really go into documentation. It's now important. Sorry for not being a real nitty technical idea, but it has to be done. You need to use a proxy, and then there are some heuristics that would allow you to think about whether something might be a parameter. So you don't have to fuzz every aspect of the request, but can focus on some things that might be more valuable. Now, going from here, let's spend the last few minutes of the talk about automated pen testing. So what is automated pen testing about in the first place? So not a lot of you are using that. You should, by the way. It's not replacement for manual pen testing, but it saves a lot of the hassle, and it's a good start for manual pen testing. I want to share with you what actually automated pen testing does, because people run AppScan, run burp, run WebInspect, and I want to get somewhat into the under the hood. So automated pen testing has two parts. The first one is usually called crawling. Crawling is detecting essentially the attack surface. And essentially, historically, it was based on links. So you would follow the links. Open source, early on, scanners still do only that today. It doesn't work anymore because there's so much Web2 and Ajax there that links are just not enough. Also, just parsing JavaScript to find links would not work either. So a modern scanner has to run JavaScript internally and do breakpoints on the actual Ajax call. So essentially something like a smarter version of proxy in order to detect those calls. And this is sort of the complexity that the web scanner has today. It's a pretty neat technology. It's not easy to do. Not a lot of scanners out there do that. I actually know just of two, but maybe there are 3 or 4. The second phase would be attacking. And attacking falls into sort of 2 different aspects. It's much closer this time to what you do as a pen tester. It's just automated. It has the fuzzing part, which is trying to send abnormal values into parameters. But this is a bit too simplistic. There are a second group or family of tests I would call session-based, where you try to create a workflow that would cheat the application into something. I'll give you a good example of that. You'll log in automatically as administrator. You'll crawl and get the surface, and then you'll try to go directly to everything as a user. And if you get to everything that an administrator can get to as a user, something might be wrong. So that's a good example of that. Attempting to do testing for cross-write request forgery, for example, okay, might be a session-based thing. So again, a lot of comparing different credentials, different users. That's essentially what the automated pen testing machine does. So essentially, you need to understand request generation, which was either links or running JavaScript. Understand what parameters are, which is tough if they are not standard. And understand session management. Again, for an automated tool, it's pretty tough if it's not standard. So all those are pretty big challenges for automated web testing of web applications. I'll remove that from the table because, as I mentioned before, this is something that even if you have to tell it to the scanner, is still worthwhile because you just have to teach him something new. What you do have to make sure is that your scanner actually supports more non-standard methods for session management. So that it knows, I mentioned the test about comparing logging as a user, as an administrator, and keeping a session. If you do it for normal web using session, it would be a cookie. If you do it for a RESTful API, probably a header, a different header. So the scanner you're using has to know to keep a session in a header, for that matter. Even if you need to teach him that the specific header is a specific name received by the login, still it needs the technical capability. The 2 other issues are way more complex. So I think we've beat the challenges for that. I mentioned them more than once. What can we do? What would be the solution? So this is sort of the idea that actually I came up with when we started looking into that for WebInspect. The first thing you need to do is what I call define rules. So define how to explain to the scanner the RESTful API. Why not just WADL? So it can be WADL, but WADL is very complex for the pen tester. So the rules are usually more, and that's very small, and the projector is not very good, so sorry for that. It will be available online, of course, and if you want me before that, send me an email. It's ofr@hp.com. That's too short to forget. I went to HP just to have the shortest URL in the world. That's the only reason. So essentially, what we have here is a bit similar to the rewrite rules I showed before. It takes a URL and have a regex part to it that breaks into what are the parameters here. So this is the simple part where it's about URLs. If you want to go into headers, into actually breaking JSON and stuff like that, you need something which is not a one-liner. It's sort of a request editor in which you take a sample request and point to what would be the parameters in it. So that's sort of a method that's sort of easier for pen testers than Waddle to model how the application, the RESTful API works. Now, how would you populate that? So you can define it manually. You can import from Waddle or from documentation or from actual source, as I mentioned before. The trick we tried to do was to do it in an automated manner. So Waddle is easy because it's a standard. From configuration, we can support a certain number of known configurations. I showed you the .NET one, mode rewrite, stuff like that. And the nice part, and we are looking into that, would be to take it, to guess it from documentation, from textual documentation. Because, you know, it looks like a URL, it has curly brackets, and it's a parameter. So, and it actually works. You'll do it by examining the documentation. A smart tool can try to do it also. And again, you can only suggest the rules, and then you can mark if it's included or not. What would we use those rules for? So the first one would be, of course, fuzzing. You'd fuzz using those rules. So you have a much wider fuzzing. The other thing is, pretty interestingly would be to actually, when you run the scanner, not the attack part about fuzzing, the scanner, to actually detect, you get a URL or a request in the scanning process, and to understand that, you would apply those rules to it to understand if it's part of an API. Okay? So the rules should be more generic than just to point to specific API entries. They might point to how an API looks in this specific design pattern. So, and then you catch the specific API call and you can fuzz it once you find it in the crawling phase. Saying that, I want to get smarter. I don't want to stop here. That's just a methodology. The second thing we do, and actually we do that, is to ask the server. When I said configuration, when I said application source, if you think about files, if it's actually file-based, so the file attack surface, all these are known to the server, that are just not known to the client. So what we have a piece running on the application, which can disclose to the scanner all this information. So the scanner communicates with the runtime piece on the application server, and it gets actually the application attack surface. By the way, this technology is good for many other things with dynamic scanning, with web application scanning, because, for example, it can tell you that a specific input actually gets to a SQL call, rather than just being an input. So it can actually validate a SQL call, or that something that cross-site scripting is actually persistent because it gets to the database, stuff like that. So it's a pretty neat technology. It's the up-and-coming technology in application scanning. We do that. AppScan do that as well. A few others do it. So again, that's a mature scanner and something to look into. Lastly, we want to actually get smart about how we determine. You remember the slide about you trying to assess if something is a parameter or not? We try to do it on an automated way. To have something automated, guess if it's a parameter or not. So some of the things that I showed before can be done by a machine as well. So a non-star header would be a good example. I can fuzz non-star headers by a scanner as well. Other things are sort of less straightforward. So two things that are really neat and sort of we like them. One of them is the 4-4 method. So essentially, usually if you issue a request for a folder, you will get you get either a 4-4 if the folder 4-4 is the HTTP message for not found. If there's nothing like that, and you'll get a message saying you can't browse it, or you succeed in browsing it, if it's a real folder. Now, that's a good way to determine if something is a folder or a parameter. If something, so cut a URL short somewhere, anywhere, call it, and if you get a 404, okay, it's a middle thing of something you know. It means it was a parameter. One thing to keep in mind, though, it might be a 404, it might be your standard not found message. Most sites today don't have a 404 message anymore. They have some technique to tell you that it wasn't found, which is not a lousy message. It would usually be a redirection to a specific URL. But it's still a method to tell you it's not found, so it still works the same here. The second way is to look for highly varying URL segments, and I'll try to explain that in the last 2 minutes I have here. Assume you have, think about the session ID within a URL, in the middle of a URL. So you have x/something very long /y dot ASPX, for that matter. It's pretty obvious to you that the very long thing in the middle that there are fairly different values for, while the x and the y keep the same, there's a good chance they're a parameter. So if it might be also the type of value, because it's very long, but if it's just a word, it might be hard to know that from the text. So what we can do is we can do statistical analysis about the frequency in which a middle section of a URL changes while the rest does not change. And if there's something that changes a lot in the middle, there's a good chance that it is a parameter. Luckily enough, we can verify it using this method, the 404 method. Neither of them is foolproof. That's why both of them are suggested. Keep in mind that we don't need a 100% success factor. As pen testers know, we need to get to as much as we can to see if there are vulnerabilities. And when we create a scanner, want to minimize the number of requests we send for the maximum value we get, because it takes time.
Do URL parameters tend to end up in the middle? Or usually they're at the end, aren't they?
So give me a minute to sum up. No, because we are into questions. So essentially, I want to summarize in a minute. We talked today about RESTful web services. It might be for some the most important part you got out of today, because we really tend to talk about it, but it's hard to know what it is because it's not something very specific. So the message is not very specific, and refer to my presentation for a few characteristics which are common to it when you get to it. Second, we did try to discuss a bit about its security, which is just like web, and then the challenges and solutions for how to pen test it, which was mostly about the attack surface. How do we determine the attack surface? To solve that, I sent you first and foremost to the documentation, but then offered a few more practical solutions as to how to look into the web application, to the requests you have, and determine if something leads to additional URLs, is a parameter, etc., etc. Lastly, I talked a bit about automation and pointed out to things that can be also done in an automated manner, which is harder in this case, to detect the attack surface for RESTful APIs. So now for questions, and I was asked just to give you the microphone, so that's the reason I sort of...
How often do parameters show up in the middle of a URL as opposed to, usually, at least in my experience, they tend to be at the end, and at some point they stop and it becomes file structure, but...
So it's not, in both cases, it's not as something is just 99% and the rest is 1%. It's sort of somewhere in the middle. My experience is those at the end are the mod rewrite stuff. So Drupal, WordPress, so those you see a lot. While a lot of enterprise applications, which are more of interest to us in many cases because they have a lot more vulnerabilities in the first place, and we are called in and paid to test them, unlike open source, in many cases do have parameters in the middle as well. Especially if it's a hybrid API, there's a good chance that the last part is the ASPX part, is the page, and the parameters are stuck. So last questions, I think. So anyone? Thank you for participation. Feel free to contact me, email now for more questions. I hope you enjoyed. Thank you.